Hello everyone, welcome to another presentation from Origin International. Today's topic introduces the CheckMate DAA toolkit for analyzing dimensional assemblies within the SOLIDWORKS CAD environment. The DAA toolkit is specifically designed for engineers and technicians dealing with the challenges of pre-production research and development of assemblies with multiple child parts. Let's get started. When dealing with this scenario, there are four main things you have to be able to break down: managing multiple nominal frameworks, processing scan data against multiple datum structures, organizing STLs and spot interferences, and lastly, view the stackups and find optimal fixes. All of these possible with the new digital assembly analysis from Origin International. When dealing with managing multiple frameworks, this is the most important part, and why we use the word framework, because it lays the foundation of what everything you need to analyze. It's the root of what needs to get, what ties everything together. And when you look at a single part, you're often looking at feature names, framework, GD&T capabilities, your CMM skill sets, your report formats and styles. And most important, what are the functional matings of that part? Datums A, B, and C, datums D, E, and F. And when you add multiple parts to that, you can see how difficult these scenarios are for your average metrologist. What the DAA toolkit does is break this down and make it easy. Let's show you how. By flicking over to SOLIDWORKS, the DAA toolkit resides inside of SOLIDWORKS 2022-2023. The DAA toolkit is comprised of a few things. The first one is the nominal framework, as we just mentioned. Here in this example here, we've got the brown part, which is the bottom part here. We'll talk more about that more in a second. And it has a datum A, a datum B, and a datum C on it. But so does the black part. A datum A, B, and C. And again, even the yellow part has an A, B, and C. So it's really important to have a database structure, a software that can handle having multiple datum A's in the same part. Now, that's not realistic. It's not that it's not realistic. It's the real scenario when we're dealing with assemblies and assigning child parts and how they're going to align. Is you're going to have multiple reference datums. This assembly, when it's finished, becomes just another part, and it gets another datum structure. But the nominal framework allows you to tie all this together. Once you have all of these tied together, the DAA toolkit allows you to break this down and analyze it any way you want. Here's all the data. When we loaded the scan data, here it is as measured. You're also able to say, go and create an alignment fit off of any of the datum structures that were in the nominal frameworks across all of them. So you can see how they were named: BRN, BLK, PNK. And if I just pick one, I'll just pick the top one as an example. You'll notice that it quickly, there was a little bit of a change in the color, and now you're looking at the deviations relative to just that black or that brown part's datum ABC structure. Again, green, red, and blue are your standard scenarios. On top of the color maps, you've also got the ability to, I'm just going to turn that off, look at the scan data, the way it's loaded in from the model. And I'm just going to go and hide my CAD model, hide my CAD. Just do that real quick. Hide all these. We don't need to see them anymore. And the reason that we want the STLs visible, and I have colorized them, the user can colorize this any way they want, is you've got the ability to just say, I want to section this scan data, keeping in mind that everything was moved and is relative to the datums, how you analyzed it, is you're able to walk through the datums, the scan data, and be able to section it. This is the most important thing. I'll just say section. And I'm going to go down one more, just say capture edges as a group. You can see we got another group there, but you've got the analytical and visualization tools now to see how you actually have, if I go straight down on this view, how we have an interference fit between the black and the purple part. That's really important to be able to drill down quickly and see how parts will not fit together even in their datum A, B, and C optimal conditions. So using the DAA toolkit from Origin, you are able to get to these interference fits quickly by stacking alignments on top of each other with the stacked fits, you see that there, and be able to simulate mechanically assembled parts by their datum structures without the parts being in the same room. Let's see what the DAA toolkit can do for you.